Hi, welcome back to Chapter 8 of Calculus with Mrs. Shuey. We're now on Section 8.2, Areas in the Plane, and I believe this is going to be done in 2 videos. Lesson 8.2 does have a quick review. If you'd like to work out these problems, pause the video and I'll show you my solutions on the next page. Go ahead and pause now. All right, here are the solutions as I worked them out for these problems. If you want to take the time to work through these and make sure you got the correct answers, please do that and go ahead and pause the video now. I'm not going to take the time to go over each problem. If you have questions, please feel free to post something in Google Classroom. Okay, so this lesson is about the area between curves. So instead of just looking underneath one curve, we can look between 2 different curves. So you may have seen problems way back in geometry when you had to have this blob, you had to estimate the area and you counted up little boxes and things like that. Well, now if we have a function that defines maybe the top part of this blob and the bottom part of this blob, we could find the area in between it. So that's a very simple interpretation of how this could be useful later. So let's go ahead and get started. This is a picture of what we're going to be doing. So we're going to partition 2 different functions. So we got a function on the top and a function on the bottom. The 2 functions do need to be continuous. We're going to partition it into vertical strips of equal width, and that width is delta x. Each rectangle has the area where the height is f of x minus g of x. So the height of the function, and they're using the midpoint. So the f of x there minus, minus g of x here, and that gives you your height, and then our width is delta x. So the area of each rectangle is here. We can approximate the whole area by adding all those up. So there's the sum of all those areas. Now, as we let delta x get smaller and smaller and smaller, we're going to get a more and more accurate approximation. And so then we have the integral of f of x minus g of x times the width, which is delta x. So the formal definition of that is if f and g are continuous, they have to be continuous, and f of x is greater than g of x on the entire interval. So if they cross each other, then we have to break it into parts. But as long as over the whole interval, one of them is bigger than the other, we can find the area by subtracting those 2 and integrating that on the interval times d of x. Here is our first example. So we're going to find the area of the region between cosine and sine on the interval from 0 to pi over 4. So just take a quick memory of what that might look like. So cosine of x starts at 1, and sine of x starts at 0. Whee! And then we are looking for the area of the region between 0 and pi over 4. Well, this is pi over 2, so pi over 4 is right here. So we're looking for the area of this region. Top of it is cosine, and the bottom of it is sine. So you need to know which function is on top. So since cosine is on top, we're going to start with cosine of x, and we're going to subtract the sine of x. And we're going to integrate that on this interval from 0 to pi over 4 dx. And that's the setup. Now we just have to do that. So if we want to take the integral of cosine of x minus sine of x dx, we need to take the antiderivative of cosine, which is sine, and the antiderivative of negative sine, which is positive cosine, because derivative of cosine is negative sine. And we're going to evaluate that entire thing from 0 to pi over 4. So sine of pi over 4 plus cosine of pi over 4 minus sine of 0 plus cosine of 0 is sine of pi over 4, square root of 2 over 2, Cosine of pi over 4 is square root of 2 over 2. So we're going to add those two together. Square root of 2 over 2 plus square root of 2 over 2. 1/2 plus 1/2 is 1. So I have square root of 2 minus sine of 0 is 0, and cosine of 0 is 1. So this is 1. So the answer to this problem is square root of 2 minus 1. One more example that's maybe not quite as clear cut. We are going to find the area of the region enclosed by the parabola and the line. You're welcome to draw this. It sometimes helps to get a visual, especially in this section. Excuse my graphs. I'm drawing on a little drawing pad here. So x squared minus 1 would be a parabola that starts at -1. And the line x plus 1 starts at 1 and has a slope of 1. Whoops, I kind of missed there, but that should go through the same point down there on the bottom, or I should say at -1, 0. Now, the limits of integration are found by solving the... we want the area enclosed. There we go. So we need to find the area of this stuff inside here. So in order to do that, we need to find these points where they intersect. So that's why that was on the warm-up. If you did that, we need to find where these intersect. So you can probably tell from my little picture, but you could also solve them by setting them equal to each other and solving. But this is at -1 and this is at 2. So this point up here at the top is 2, I believe. So we're going to integrate from -1 to 2. And which graph is on top is the line. So my line is x plus 1. And I'm going to subtract my parabola, which is x squared minus 1. And to simplify that a little bit, we're going to integrate from -1 to 2. If I subtract these, I get -x squared plus x plus 2. dx. Okay, so that's just subtracting those two middle things to clean it up a little bit. Now I will do the integral. So we're going to do antiderivatives. The antiderivative of -x squared is -x to the third over 3 plus the antiderivative of x is x squared, 1/2 x squared, or you can do x squared over 2. And the antiderivative of 2 is 2x. We're going to take that whole thing and evaluate it from -1 to 2. So when you plug in 2, you get -8/3 plus 4 over 2 is 2, plus 2 times 2 is 4, and minus, when we plug in a 1, -1, we get positive 1/3 plus 1/2 minus 2. So you'll want to verify what that equals because I see a mistake on my work. So I'm going to grab this little, oh no, just a minute. I'm going to grab this little box and move it and see if we got 9/2. So make sure that equals 9/2 or that I didn't mess up somewhere. And that is going to be as far as we go to on this part. I'm going to go ahead and pause the video and let you work through a few of these problems, and then I will continue with part 2.